1,125 foot cube open top tank of water, has a square base of X feet on a side and is Y feet deep, is to be built with the top flush with the ground to catch runoff. The cost associated with the tank involved not only the material from which the tank is made, but also the excavation charge proportionally by the product XY. The total cost is there. What values of X and Y will minimize it? A zero.
If you don't build the tank, it will save you a lot of money.
So let's do this.
What if you build the tank and sell it? That'll save you a lot of money.
Yeah.
So what I would think about doing is let's go ahead and find an expression for the volume of this tank. The volume of this tank is going to be X squared times Y equals 1125. Okay? So then let's do this. Let's say then that Y equals 1125 over X squared. Okay? So we want to minimize the cost. We want to minimize, here's my expression for how much this thing's going to cost. So what I want to do, X and Y are the two things that change in this. So let's plug this in for Y and say my cost in terms of X is equal to 5 times X squared plus 4X times 1125 over X squared plus 10X times 1125 over X squared. Okay?
Now plug that into Wolfram.
Okay? So cost is equal to 5X squared plus 4 times 5 times 1125. 20 times 1125. I probably should be able to do that in my head, but it's Monday. I'm tired.
4,500 or 4,500. Right?
22,500 all
what?
over X plus 11,250 all over X. So I can add those two together. So then I've got my cost in terms of X is 10.
You have 15 seconds.
5X squared plus 33,750 all over X. Take the derivative. Take the derivative, so I have 10X minus 33, hold on a sec, all over X squared. Is that what you did, Tess? Yeah. And then set that equal to 0. Set that equal to 0, and you're going to get what X is, and then you can figure out what Y is. Okay? So tonight, for homework,